All right, so this is Noir for Aztec. We're going to go over basically the various ways that you use Noir, or like we're using Noir at Aztec Labs. Actually, let me step back. I'll introduce myself first. My name is Josh. I lead the developer relations team at Aztec Labs. Been working with Aztec for a little over 3 years, so I joined actually a little bit before we even announced Noir publicly as a thing. So it's been really cool to see it launch, evolve, see how the community's using it, and just, how the engineering team has been using Noir to just build this roll-up that we're building at Aztec. So in terms of structure of the workshop, I'm going to talk a bit about how Aztec is using Noir. Then depending on how much time we have, we can actually do some workshopping things, but it's just going to be going through essentially the counter contract tutorial in our docs and kind of like explaining the things that I mentioned in the slides along the way, the various ways that Noir is being used.
You got QR on the slides?
Yeah, it's right there. So I'll linger here for a moment. So I'm going to talk a bit about what Aztec is, talk about how we use it in various ways, which is essentially smart contracts. We're using Aztec, the network, for state management and function execution of Noir programs. Noir by itself is stateless, so you're just essentially creating statements that are proven or verified. Aztec, the blockchain, makes this more capable and more featureful through state management and function execution. We highly leverage macros when writing Aztec contracts. All of the protocol circuits that enforce like the Aztec protocol rules are written in Noir as well, as are accounts on Aztec. And then we're using some cool non-blockchain specific use cases in our testnet. And then, the example I want to talk about is the counter contract. So what is Aztec? Aztec is a layer 2 on Ethereum. So it's a ZK rollup where all transactions are proven using Noir, whether that's private execution or public execution. So it's nice to think of it as an execution environment and state management system for Noir programs, because by itself, Noir is basically just a statement checker. You have these circuits that you write, and you can generate proofs of statements, and then other people can verify them. You need to plug those into web applications or other blockchain networks or Aztec to actually make those like execute and make them useful. So some key components that differentiate Aztec from other networks: there's private and public state, and there's private and public function execution. Whereas most blockchains you guys are familiar with just have these public components. So
like other ZK roles as well, just public.
Yes. So I haven't built on like Alio, but in terms of like ZK Sync or like Scroll or other ZK EVMs, they all have public state. And they're not ZK in the sense of zero knowledge. They're using ZK for like essentially verification of computation. So it's just like validating that state transitions are correct, and you can do that. You can verify those transitions very cheaply and quickly using zero knowledge proofs. But essentially, there are zero knowledge proofs where all inputs to the circuit are public, whereas on Aztec and Noir programs, you can have private inputs to these circuits.
And one follow-up, how did Aztec change, or did it change? Because I remember it was around like already 5-6 years ago, and there was some e-app, ZK Money, where it created like a account.
Yeah, so
what was shut down, and I don't know what happened in between. I didn't hear about it much actually. So
yeah, so I think this is the fourth blockchain that Aztec Labs, the company, is building. The first two were simple confidential payments networks, very relatively simple rollups. So you could send and receive money, like you could hide basically sender recipient token in amount. But beyond that, it wasn't very capable. Then there was Aztec Connect, which we launched. That was like mid 2022. That had a bit more functionality where there was this message passing concept where you could like send bits of data from the rollup to the L1 and do things. So like we had a Uniswap integration, so you could do trades, you could open and close like borrowing and lending positions, I think, on wasn't LUSD. It was one of the, I think it was LUSD actually. But basically we stopped working on those because we had the tech and we had the capability to build what we're building currently, which is full smart contract programmability and composability on this layer 2. So basically just focus all engineering effort on basically the end game, and we don't need to like maintain these previous rollups that we've built. So the biggest component of this is like Aztec is a layer 2. We have smart contracts with programmability, and these smart contracts can interact with each other. Yeah. So these smart contracts have private and public state. Private state is essentially just a set of Merkle trees stored on Ethereum. The roots are stored on Ethereum, and then we're updating these things by creating note hashes and creating nullifiers in a UTXO-based model to maintain privacy. You can't build a completely private system in a like public state tree architecture similar to like what Ethereum has. Even if you encrypt all of the values in your smart contracts, every chunk of data has a specific location in that tree. So if you're updating an encrypted value, you're going to that specific location in the tree and updating that value. So you're revealing a lot of information just by interacting with that sort of architecture. So this private state system is built on a UTXO-based model where there's essentially just a bunch of, we call them notes, just put into a big tree. And those are essentially commitments to private state. And then if you ever want to update that private state, you have to invalidate some note hashes or some of that private state. You invalidate some of those UTXOs with nullifiers. And those nullifiers are deterministically derived from notes, but they're not directly linkable without some secret.
Do the fact that it being nullified, does that add a lot of latency anywhere, given that there would, like every single state update is due a nullifier?
It doesn't add latency. A nullifier is essentially just like essentially a 32-byte value. So it's just a.
But they all have to be stored, right?
Yeah. So it adds storage cost. Yeah. But we're posting these like all of the updates, all the note hashes and nullifiers to the DA layer on Ethereum blobs.
The DA layer and this
Yeah.
was.
Yeah.
So this is similar to how semaphore protocol works now?
I believe so.
So that you
Yeah, I'm not sure how they nullify, like, if they have a concept of, Pedro, you may be familiar with, I know you've worked with Semaphore before, but just in terms of like making commitments and then nullifying data, Semaphore has a similar,
it is a tree.
yeah,
It is another tree for the nullifier.
yeah, yeah. So the short answer is yes.
I mean, to access the private state and this nullifier will, each user has to keep some private data in order to calculate these nullifiers and use them.
Yeah, this gets into like some of the deeper aspects, but in terms of when users are interacting with Aztec, there is like, we call it the private execution environment, but the private execution environment runs locally on your device, and that is like basically holding your private state for you. So it has your secrets, it has your information, and it can generate these nullifiers to invalidate old state. In terms of how it relates to Noir in terms of contract compilation, we have a tool. When you're developing on Aztec, you use Aztec Nargo, which is just an Aztec flavor of Nargo. It's largely the same. If you look at our Aztec packages repo, we're actually just pulling in Nargo, the Noir compiler, into our mono repo at a specific tag to do a lot of our compilation. And private functions that you write in smart contracts are just Noir verification keys. They're the same thing. Public functions are different because they're being executed by the node network similar to other blockchains, but they're essentially producing AVM bytecode, Aztec virtual machine bytecode. So there's just like public functions are producing opcodes that are then executed according to the Aztec virtual machine spec.
So these private functions, there are limitations in terms of how flexible they should be to click and receive and
Yeah.
like you need a different private function for each specific.
In terms of like for the developer experience, you essentially, I can show this a bit later, but you basically just add like a private annotation to any function that you want to run privately on user devices, and like the compiler handles making all of these verification keys for you. You just have a contract that may have like 3 private functions and 4 public functions. You just run compile and it produces an artifact that you'll then serve with your web application or whatever. And then when a user calls whatever private function, the SDK will just generate it.
The workshop before, right, we were discussing how each circuit would have a different verification keys, and
Yep.
taking the simplest example of showing that your number is not equal to mine, if you give me a different guess, I would need a different circuit and a different verification key. So the question here is,
You don't need a different, if like just for guessing or like checking or like doing verifications, you don't need different verification keys. Like these verification keys, when you do compilation and you generate your contract artifact, those are essentially set. And then if anybody's ever interacting with that contract that you wrote and compiled, they're using those same verification keys. And actually, when you deploy contracts onto the network, there's commitments to those verification keys that you're using in your smart contract. They're actually kind of baked into the smart contract address in a way, because there's a hash tree that's built up that includes the verification keys. So yeah, we have a
Technology one. Private functions, public functions cannot have private inputs, right?
correct. All inputs to public functions will be public. They'll go on chain, yeah, and they need.
Private functions can have public or private inputs.
In Aztec, when you're running private functions, practically speaking, they'll all be private inputs. But like you could pass some information from a private function to a public function. I think the next slide is on function execution. There's some interesting things with how that's set up.
In terms of like how the code looks in Noir.
Yeah. Yeah, and like a difference between, I say many entry points, but like Noir circuits define a main function in your file, and like that's essentially what defines the circuit. But when you're writing Aztec contracts, any one of those private functions could like essentially be an entry point to, like they're just all circuits themselves. So I touched on this, but private state is represented by notes. There's a note hash tree that holds commitments to all of the private state on the network. So when we're sending private notes, like we're sending tokens to each other privately and updating this private state, all of those updates are going into this note hash tree and changing the root of that tree. When I want to spend notes, I need to nullify my old token notes, and I need to create new notes for whatever recipient I want to give them to. And I mentioned, nullifiers are deterministically derived from notes while remaining unlinkable for privacy reasons. And then when I create a note for somebody, I want to make sure that they receive that note information so they know that they should add this note to their private execution environment. And they should be like, okay, Josh sent me this note. I now have it in my database so I can spend it. Currently, we're encrypting that note information and putting it on chain so someone can just scan the chain and find all of the notes that are relevant for themselves. But I think we'll add flexibility around this in the future just to reduce cost and makes it more flexible. Public state management is just like other public blockchains. So your mental model for how blockchains traditionally work maps. There's this weird case where we actually have this cross between private and public state where since these private and public are happening in 2 different execution environments, public state isn't directly readable when you're executing things in private, and private state isn't directly readable when you're doing things in public. So we have this special data type called shared mutable. It's shared because it's shared between private and public, and it's mutable because you can update it. But yeah, there's some nuance there. I'm not going to go into the details, but it's one of the difficulties of working in this system where there's multiple function execution environments. Shared mutable. Yeah. So I mentioned there's private execution and public execution. The reason we have these 2 different execution environments is basically to maintain like as much privacy as possible. And if you want things to be truly private, you essentially have to execute them yourself. Like you can't send your secret data to a third party in the cloud or to a remote blockchain network and have them execute information for you. Because as soon as your secrets leave your computer, you can assume they're no longer secret, right? You're trusting some other third party to maintain your secrets for you. So you have to do private computation with secrets locally on your machine. So when you're doing this in your private execution environment that we've built for interacting with the Aztec network. This private function execution is going to produce outputs that you send to the network that are then verified using the protocol circuits, and then public execution happens remotely on nodes, just like on Ethereum. But like when you do private execution, you're going to produce a proof of correct execution. So when you execute these private functions, you're going to have private inputs, and you're going to generate a proof that basically says, hey, I'm interacting with this contract, I have these inputs, and it successfully executes. It spits out a proof. There's also going to be these note hashes, which are commitments to private state updates, and then nullifiers if you're invalidating previous state. You're basically sending these three things with some other things to the network, and the Aztec nodes are going to verify those proofs and the inputs that you provide, and basically say, okay, what Josh executed privately locally is following the rules of the contract that he's interacting with, as well as the rules of the protocol defined by all of the nodes running the Aztec software.
So if I, just as a Web3 dev, if I want to like go beyond the contract and like basically verify things, for example, the availability level check. Does this correspond to state as much as like can see that from in private state, and has this been nullified yet? So these kind of things might do on either scan. If you were real, you're just going to hit Ethereum. Are there tools for that, or does it kind of have to all go through like state calls, contract calls?
So we're posting all this data, like so you can recreate the state tree basically, all the necessary state trees on. It'd be kind of a manual process right now. We don't have the tools, like because we're currently still like working on our testnet. You can go to like block explorers now. Block explorers are getting more feature rich, where you can see all of the note hashes and nullifiers that are generated as part of a transaction. All of the logs that are emitted. I think Aztec Scan is adding contract verification, so you can basically upload like the artifacts and basically say, oh yes, this contract I'm interacting with has this functionality. So we're getting there, but yeah, right now it would still require like a good chunk of manual work. But in theory, we could build these things, yeah.
How do you deal with race conditions? I'm just like thinking of the ZQL model as this. Now, as far as I understand, there is a centralized sequencer that sequences transactions, and then proofs are generated not for each transaction, but for blocks, so like even sequence of blocks. Like these 10 blocks all together in this sequence are valid. But if I say we have some kind of DEX, and I want to make a trade, and I do a local proof with some private state on my laptop, and you do the same on your laptop, our transaction conflict, and only one of them can be valid. So how is this resolved?
So private state is scoped to specific accounts. So typically, you're not going to be updating private state that somebody else also has access to. This is private to you. Like someone else would not be able to access that piece of information because it's like it's basically scoped to your account. DEXs are an interesting example because for a lot of the current DEX designs we have, it actually requires public information in terms of like how many tokens are in the pools. That's how you determine the price. Like that part actually needs to be public. So like if we look at building DEXs on Aztec, what you actually get in terms of privacy is you don't know, someone can do a trade, it's going to actually have some public execution component, which is the actual swap. But the privacy that we get is we don't know which account is actually doing the trade. So you basically get account privacy, but you don't have privacy of like which assets are being swapped or how much is being swapped. And since that's happening in public execution, it's like on Ethereum today, it's like many people can be swapping ETH for USDC at the same time on Uniswap, and the block builder just chooses the order in which to execute them.
Could you maybe give an which is like what could be the use case where it would be valuable for me to update it, but no one else has access to the state. So it's not like some shared state, but state linked to my account specifically.
Yeah. I'm particularly interested in like voting applications and like interacting with DAOs, where essentially you can basically validate that someone's in a specific set to do some on-chain action. It's like, okay, to participate in this vote, you need to hold these tokens or have this NFT or something like that, and then you could hide which users are actually voting on things.
So if I want to vote, then what is my private state, and how do
you could have like a certain number of tokens in your private state that qualify you to participate in a vote, or you could have like a specific NFT that's been issued to you that allows you to participate to vote. So you would, like in private execution, you'd do that check that you qualify to vote, and then after the private check, you can in-queue a public function call that basically actually does the vote.
Just want to proving, I don't like, in this use case, I'm not executing anything on my private state. I just prove that my private state is in this, like, satisfies these requirements. Just proof, and the proof allows you to proceed with the public execution. Right?
Yep. Yes.
But you're actually also modifying the private state properly because you don't want to allow to vote twice, right? And probably privately you need to say
that user variable as variable, like head project, and it's false, and then I can only produce a proof if I simultaneously switch it to truth, and then I can no longer produce any other proof.
Right. I don't know the specifics now, but for example, I guess like
a cool pattern that I've seen is for like voting specifically is you can actually use the nullifier tree for whatever you want. You don't have to use it specifically for like updating private, like invalidating previous like note commitments. So you could create a nullifier, like somebody participates in a vote and you just have the smart contract emits a nullifier based on some conditions, like maybe it hashes message sender. Well, message sender is going to be private, so that's not a good input to the nullifier generation. But you can customize how you generate a nullifier and then emit that. So if the same person tries to call the vote function twice, it's going to fail because a nullifier for that person already exists. But you need a way to like generate that where it's going to be deterministic for the same user multiple times.
So just a follow-up about the private-public thing. They're separate, right? So you can have private tokens, but then it wouldn't be possible to actually trade them on a public Uniswap pool?
So in our current, we're figuring out what token standards look like on the network currently. We've been working with DeFi Wonderland on this, and they have a pretty good standard. They have a repo where it's published, and I think they shared a blog post recently. But the design pattern there is like, there's in a single token contract, there's oftentimes a public balance and a private balance. And you can move tokens between the public state and the private state. So it's like, oh, I want to shield my tokens. Like I have a public balance of tokens, I want to shield them, so I'm going to put them in my private balance. Or like I have a public balance, I actually want to send them to you privately. I can make them, I'll remove them from the public.
Distinguishable from like sending them to someone else or different accounts.
Yeah, depending on how you're interacting with them, like sometimes the sender or recipient's public. Obviously, if you're interacting with public state, some of the stuff's going to be public, but you can look at the function interface and be like, okay, this is going to reveal some information. But if I have private tokens, I want to send them to you in private, like the only thing you see on a block explorer is like someone did something. You don't know who, you don't know what contract's being interacted with. You don't know what the execution logic is at all.
Yeah.
Good, back to your thing, did mention paying the nullifier tree, so that means that you can basically introspect into the data availability, into the nullifier tree in Noir?
It would be, you'd have to look at like the transaction history of Aztec to see which like nullifiers are generated, but yeah, you could reconstruct that and see like all the nullifiers that have been generated.
That sounds quite big then. So you'd have to feed in basically the whole tree, or feed in like all the tree in order to prove that something is nullified or not nullified.
Yes.
But that's more efficient than just maintaining the state and voting all the votes.
Well, I don't know. I'd have to like try it and see. Yeah.
Then the modifier cannot be linked to the modifier is a commitment to something, right? So if you cannot link what you're committing, then you can just store it in a tree in the voting contract, right?
You could generate the nullifier in a private function and then pass it to public, and it gets emitted. And yeah.
I mean, you just need to ensure that you emitted this specific nullifier for this specific application, right?
Right.
So usually the nullifier, at least in the set of focus correct, it takes some information which restricts the scope of what you're nullifying. So for example, it could be the string body up plus some secret.
Yeah.
You just need to track those.
Yeah. And the protocol rules will check like if a nullifier, that exact nullifier already exists, the transaction will fail and it will revert and it won't apply the updates. Yeah, so private execution can enqueue public calls. So you can actually be executing a private function and say, oh, I want to execute these 3 public functions as a result of this private execution. And they'll all succeed or fail atomically. So like if anything in private fails, the public execution won't happen. If a private function call enqueues public calls and any of those public calls fail, the private state updates associated with that execution will also not be applied, so it essentially reverts. So similar to how you understand Ethereum, where like if any of the transaction logic fails, the whole thing reverts.
If you call the public functions after a private function, is on this function you called in on the invoice.
Sorry?
If you chain some public functions after a private function, then you're shooking invisibility into what function you called.
Yeah. Right. Yeah, so you can enqueue public function calls. All of the inputs to those public functions will be public. They'll go on chain. And then you do reveal information about like which contract is calling those public functions. So if you're calling, yeah, there's some bit of information that's revealed there. We have these various contract macros that are used frequently when writing contracts. So like writing a contract looks like a Noir program, but it has these annotations for these macros. It's just private functions get the private annotation, which just injects relevant private context when it's actually doing execution. Same with public. There's view functions that are essentially read-only contract functions. So if you want to get state from another contract, it may expose a view function that allows you to read that state from another contract. There's a utility annotation, which is essentially an unconstrained function. And I don't know if Pedro talked about unconstrained functions in the previous workshop, but essentially there's no constraints on these functions. Like they're not actually doing generating proofs or like enforcing the computation. So it's a way to generate like optimized, well, in the case of Aztec, you're basically using unconstrained functions when you're not doing on-chain execution. So if you just want to like do off-chain reads of some state of a contract, you might define some unconstrained or like utility functions in your contract that say, oh, I just want to like return some of the state variables. And like this is for your private execution environment that's running in the browser or like in a wallet, and you're just like using this utility function to like read contract state. That's primarily how they're used. And the reason we don't need to enforce like constraints on the return values there is essentially you can assume that the incentives are aligned for you to be reading correct data, right? Like you want to be reading the correct data from the contract. So we don't need to constrain that output. We're doing it for ourselves. We have an initializer annotation, which is essentially just a constructor. It's not required that you call initializers for calling all functions. But if you want users or if you want a contract, you can enforce that initializer function is called before any other functions, if you require some setup or something. We have the note annotation for actually defining what notes are, and this basically just adds some additional methods to the struct, Like it adds getting a node ID, computing the note hash for that note that you define, how a nullifier is computed, how to pack and unpack it for efficiency. There's a storage one for defining how storage is laid out in the contract, and then one for tests as well, similar to regular Noir. We're using Noir for all of our protocol circuits, which is doing proof verification. We're actually doing a bunch of recursive proof verification, so all private function execution generates proofs. Nodes are verifying those proofs, and then also generating proofs of correct execution, which includes the verification checks of private execution. And then when we're building blocks, we're doing recursive tree building, proof generation, and verification of all of the transactions in a block. So ultimately, we can build a transactions tree and then a proof of a whole block, and then submit one proof to Ethereum that when it checks is basically says, oh, all of the private execution and public execution included in this block is valid and follows the protocol rules and the application circuit rules defined by the smart contracts that are called. The protocol circuits ensure that state management is done properly, so it's tracking these note hashes and nullifiers and it's validating the state transitions. I mentioned how it's aggregating all of the proofs. One of the more advanced topics in Aztec is account abstraction, but like essentially every account on Aztec is a contract. There's no concept of like externally owned accounts. There's nothing that's just controlled by a private key. It's essentially just a Noir program that has a specific function implementation that does essentially an authorization check. And that authorization check can be anything. So like our example account contracts in our monorepo right now do like verify Schnorr signatures and ECDSA signatures, so you can use keys. But like this is just a Noir circuit, so you could have the circuit be like a password checker. Like you could have an account contract that's just controlled by a password. Or you could use like ZK Passport proof check to basically say, oh, someone needs to be able to provide a proof that they have a passport with this ID or something to control an account. There's a lot of cool things you can do with this, but like, it's very unopinionated at the protocol level.
You control two accounts at once with this idea, like because this is similar to Bitcoin. You take some other, like you run a circuit or a script, and you can fill in whatever you want. Fees are paid just implicitly. There's no amounts and so on.
Yeah.
So can you control two accounts at once just by proving that they can access more than one?
I don't know what that would look like in practice in terms of transactions have to originate from some place, and you basically think of account contracts as like an entry point of a transaction onto the network, and the account contract is then going to call other accounts.
That's not part of the proof. That's my question basically. So is the target, if you want, of the transaction not part of the proof? That's like an extra failure.
I guess it would be part of the proof in the sense like you're specifying which contract you want to interact with when you're generating an Aztec transaction. So you would specify like, oh, I'm going to like create a transaction that interacts with this contract calling this function. So you're like specifying the entry point of the, but like you could have account contracts, like maybe similar inputs could go to multiple contracts, but.
Is it realistically possible to obfuscate or hide the logic that an account contract would use to verify your?
Yes.
It is.
Yep. You could have an account contract that is not actually even deployed to the network and use it to send transactions to the network. Because essentially, gets pretty in the weeds, but there's a hash tree that has a whole bunch of inputs, like various things that basically ends up in the account address. Or the contract address. So the contract address essentially includes a commitment to all of the private functions that are included in that contract. So if I'm executing some contract logic, I can prove that just with the address that I'm interacting with, that address includes some private function logic. And that private function logic might be account authorization logic for sending, interacting.
Private function logic, you mean the actual function is private, like you cannot see what the function is?
Yeah, you don't have to publish that anywhere. Yeah. So you can have complete, like we could deploy an escrow contract or something similar where, well, we wouldn't technically have to deploy it, but it just has private functions, and we use that to escrow some funds, and then it's like release funds based on some conditions that are met. But we technically wouldn't even have to. We wouldn't have to publish the code anywhere so nobody would actually know what that logic is, and we might not even have to actually deploy the contract to the network, depending on what it's doing.
That's basically just a hash of that private function.
The contract address, yes. So the contract address essentially acts as a commitment to all of the code in the contract itself.
Is every private function its own contract then? Or can you
No.
have one contract with public and private functions?
Yes, the latter.
And then how would it be represented, private functions?
Well, they're like if I don't deploy the contract anywhere, well, with public functions, that contract does have to be deployed because essentially the remote network of node operators is executing it. So you have to deploy a contract with public functions to the network, because you're having these other people essentially execute the logic. But with private functions, that they're not executing anything. So if you just have this commitment to specific private functions that are in the contract with the contract address, that's sufficient to ensure that anybody interacting with that address is following rules defined in whatever specified.
You wouldn't even see the private functions on that same contract.
Correct. But if I wanted anybody to interact with that contract, I'd have to give them the code so they could execute it on their side. So like if you and I have a private escrow, I'd have to like write the escrow and then give it to you, and then I can execute my part, you can execute your part. But as far as anybody else is concerned, they have no idea what the heck this thing is even doing. If it's only interacting with private state, like they don't even know what the side effects of these interactions are. It's all encrypted and it's just generating note hashes and nullifiers.
So the nodes which are running this, they would obviously have some kind of code that have to run to verify that it is correct or not, right?
Yes.
But that code would, by that point, it'd be so obfuscated it would basically be an obfuscated circuit.
Yeah. Yeah. So that's basically protocol circuits are like, they're not well documented currently. Like we have some old designs in our unpublished docs in our monorepo, but like, yeah, a lot of the protocol circuit design is going into like hiding a lot of information between various steps of like the recursive proof aggregation and like, yeah, making this flexible but also like maximally private.
If I want to send money, I want to send it through ETH, is that a public function on the contract as well? Because
It depends on how the tokens, well, you mean on the L2?
Like on the URL, like if, let's say.
It depends on how the token's written. We don't have a native coin like on the L2. Yeah, I don't touch on this concept of protocol or portals at all in this presentation, but we essentially have this way to pass messages from L1 to L2 and L2 to L1, and like we can basically link any contract that's deployed on Ethereum L1 to any contract that's deployed on Aztec L2, and they stage messages to go back and forth between each other, and they're just arbitrary messages essentially. So then like bridge developers would say, oh, I received this type of message that's scoped from this specific contract address. I'm going to mint tokens. So like the idea is somebody would send ETH to the portal contract on L1, and then they're allowed to mint corresponding ETH tokens on L2. Yeah. I mean, but it's on L2. Yeah. So it's locked in L1. Yeah. And then like let's say I mint ETH on L2. I send you those tokens, and you're like, oh, I want the ETH out on L1. You send the message. It burns the representation on L2, and then you can pull it out of L1. Yeah. And then on L2, that token contract could have private state and public state, or it could have only public state, or it could have only private state. It's like it's up to the developer on what they want to do. But generally, I think most tokens are going to have private and public state components, and then users can just be like, oh, I want this to be in private state and have complete confidentiality, or I want it to be in public because I want to swap it, or I want to send it publicly for some reason, or whatever. There's flexibility there. Yeah. I wanted to mention just like ZK Passport that we're working on integrating with our testnet in like a non-blockchain way at all. I don't know if you guys saw ZK Passport. It was in this room just before a workshop on it, just before this. But the problem we're seeing right now is like testnet is essentially a proof of stake chain with nothing at stake because it's a testnet. So we can't have people staking real things. So like we have a civil problem. A bunch of people are spinning up a bunch of nodes and it's unreliable, and there's a lot of bots like airdrop farming or whatever. And a cool tool we can use for this is ZK Passport, which essentially just proves, the idea is it proves you're a human and bots won't have access to these proofs to basically say, run the node. So like we have this queue to join the validator set on our testnet. Currently it's gated because of this problem. There's nothing at stake. We can add ZK Passport check to the queue, and it's actually on-chain on L1. So it's going to be an on-chain passport check that allows a Aztec validator to get added to the queue. And then we're going to add 10% of the current size of the network to the network every day. So we can, like, if we have 500 validators running on the network, we'll add 50 validators the next day. So we can actually get more people into the network participating while maintaining network health. So that's a cool way that we're using Noir, kind of like outside of the blockchain context. But yeah, there's a lot of cool things you can do, obviously, with Noir that are not just on blockchains. For examples, automated market makers. I talked about public token pools while maintaining user identity privacy. We talked a little bit about private voting. And then there's this counter contract example that I could run through. I don't know if we want to run through the counter contract example, but we're at 1:15. I might skip this, but it's just linking to this counter contract in the docs. So if you just go to the docs, go to the build tab. Maybe I'll talk through it real quick and not just go through all the steps. But it's the first contract tutorial where, have any of you guys used the Aztec sandbox at all? It's basically just our execution environment without the networking side. So it's a place, it's like a local development environment. So you can just like spin up the execution environment, start writing contracts, deploy them, do some basic interactions before going to testnet, because testnet is in development. It has been quite stable. I think it's actually down right now. What does it do? What's the question?
Yeah, what does the Aztec sandbox like? It's not connected to a network, I just understood.
Correct.
How does it do things?
The idea is you use it to develop contracts quickly. So you can basically, like in this example, you write a counter contract. If you start the sandbox, it just instantly mines transactions. It doesn't actually do proof verification or proof creation, so it's super quick. It just reduces the feedback cycle and the iteration loop for building. Yeah, exactly. So the idea is you develop your first versions of your contracts on the sandbox, get rapid feedback, and then once you're like, okay, this is actually pretty cool, it's in a place that I want to like share with more people, then you deploy to testnet, and then, yeah, that's a widely available.
More detail, so you can
I'll say.
So is the sandbox in the browser or online?
It's just running in your terminal. It doesn't have a browser component.
So you can actually submit a whole load of transactions to test how
Yep. And actually, I built this starter repo which is a really nice way to get started. It basically does the project setup for you. If you don't want to have to like copy paste contract stuff, this is definitely the easiest way to go, because what you should be able to do is just install the sandbox and then like run the tests that are defined here. So if you want to do a bunch of stuff like quickly, these tests are a good example of like, this is a voting contract example. This has like tests defined of like setting up the sandbox, deploying the contract, casting a vote, ensuring that people can't vote twice. So there's like predefined tests here that you can see, you can run. You can actually write tests. Sorry? These are like the integration tests. So like, I mean, we're writing all of our tests internally in TypeScript as well. Yeah, so we have the Aztec JS SDK, which is, all of our SDKs right now are in TypeScript, I guess is the answer. Our node software is in TypeScript as well.
Can I generate storage proofs and verify it on Aztec?
You should be able to. There's some specific flags you'll have to add. I can look for those. There was a recent question on Discord about doing that.
Yeah, I think I asked that.
Because you want to do recursive.
No, I want to verify an EVM state on Aztec.
Right. So do you have an Ethereum storage proof like in Noir already?
No, I haven't tried it out.
Okay. Yeah, so there's what you would do. This is pretty cool actually. You can verify any Noir program in an Aztec transaction, like in private execution. So like in this example, you want to create a just regular Noir proof of some Ethereum state. So like the Noir proof will take like an Ethereum block header, a contract, or like whatever information you need to actually verify that state. And then that's going to generate a proof. You're going to pass that proof as an input to an Aztec transaction. And you basically want to verify that proof is correct in the private execution of an Aztec transaction, which should be possible. But like, that's a pretty powerful primitive when you think about like, you can just generate any arbitrary Noir program proofs and then verify these in Aztec transactions. But yeah, it should be possible. So just real quick on Aztec Starter, you can also write tests and execute them in like Noir itself. So similar in like to how Foundry, you can write tests in Solidity and just like run your tests in Solidity. It's like kind of handy for various reasons. You can do the same thing in Noir. This is like, I'd say it's mostly good. It's definitely not fine-tuned. It's not perfected, but we do a lot of testing in Noir itself. I think one of the most handy things is the scripts that are defined in this Aztec Starter. So there's like very simple TypeScript files that just show how to deploy contracts, deploy accounts, handle fees. Fees is actually quite a tricky problem on Aztec. It's not a tricky problem. It's just very flexible, which makes it a little difficult to understand like what's possible, because you can just do a lot of things with it. We have fee abstraction where anybody can pay transaction fees for anybody else. That flexibility comes with some considerations. So this example shows how to pay all the fees in all the ways.
Was there like a metering?
Yeah, there's metering. Gas is interesting on Aztec because when you do private execution, you don't have to pay the network to do execution for you, right? You're doing the execution locally in your private execution environment. Nodes are just checking the proof, and then there's going to be state updates with note hashes and nullifiers, so you have to pay for those. But then there's public execution that has metering of like opcodes cost certain amounts, like these nodes have to execute this stuff. So like there's a familiar concept of gas in public execution in the AVM, yeah. But like, you can think of like, you can have arbitrary compute in private execution because like the network isn't doing private execution for you. You can do a whole bunch of execution in private and it's not going to necessarily cost you more in terms of transaction cost. It will cost you more in terms of proof generation time for a user that wants to create the proof of the transaction. Pretty much fixed cost.
Okay, but whoever does the verification, that happens on chain and there is a gas cost.
Yes. But it's pretty much a fixed cost, like small amount. And it's not gonna like doing more private execution isn't gonna increase the verification cost. So it's just like fixed cost per transaction.
Like in the previous workshop, doing the verification on chain for that single circuit was very expensive, but that's because
It's very expensive, but that's also fixed cost essentially. Like he's like, oh, it's 1.5 million. So that's verifying it in a Solidity contract that's being executed by every node.
so that's why it's more expensive. Like if you do it in
This verification of an Aztec transaction isn't happening directly on the Ethereum chain. It's being done by Aztec node operators.
It's not even the AVM, right? Is it the AVM or directly on the clients?
Yeah.
It'd be on the node
But
software.
maybe the question is the VM gas optimized? Because you could say, verified proofs cost 10 gas fixed. You can say it's part of the protocol then and it's cheap.
Yeah.
Right? But the question is, do you have like special optimizations in that sense to make proof verification cheaper?
We haven't gotten to optimizing that yet. It's still pretty cheap. And we also haven't gotten down to the specifics of what gas or like this pricing is going to look like. Like what's the real cost for node operators on their hardware, and then, we're still have to refine the fees piece.
It
But
wouldn't make sense to have it in the AVM, right?
in the AVM,
The verification of these proofs of private consultation, you want to have it as cheap as possible, so it would be on the clients directly, right? It would be native execution.
well, no, it has to happen on the nodes because you can't.
On the nodes, but like not in the VM.
Probably not in a VM. Yeah, it'll probably just be part of the node software that everybody's running. But it,
Just like pre-compilers that are
Well,
not in the keeping, right?
Right. But it has to take the proof has a proof of the good right?
Yeah.
yeah. So that's pretty much it. No, that wasn't like super Noir focused, but and it was like kind of like a whirlwind of what Aztec's doing. But I hope you guys learned something. I hope it was interesting. And if you have questions, let me know. I'll be around here all day. So.
Are you guys doing any like? I saw like Cypher is doing like a Noir bootcamp right now.
Yeah.
Do you guys provide bootcamps where you have an instructor?
Not currently.
Are you planning on it?
Not in the near term. We just don't have resources, unfortunately. Are they doing a boot camp, or is it just? I saw that 7-hour course that they published.
It's on their website, so it's like just 7 hours, and they have it split into chapters of 4 different
Nice.
chapters.
So like self-paced.
Self-paced,
Okay.
but no lag.
Yeah. No, we've worked with other teams that do boot camps in the past. I'm definitely interested in that. But like in terms of like what we have to work on and like the resources we have, it's just like we have not recently. They're top tier for sure.
Yeah, I'm really close to it. So
Okay.
If you're interested, I can move along for you and help out.
Nice. Yeah, I think we're getting close to auditing Noir. I think we might have even started doing like internal audits on the compiler. And like once we get like version 1.0 stable released, it's gonna be a lot easier to like do a heavy investment in this sort of thing, because like this has been changing so much over the past year that it's like we can't invest in these like more heavy resources because it's just like obsolete. Like even the Cifrin people messaged us and they're like, oh, we were creating a course and we were using version 1.0 beta 0.3 in our course, and now it's 0.7 actually. So it's like, and like the 0.3 version of the docs is gone, and that's what they're referencing in the course.
I saw the first like hour, and that's what he said. So like we use 0.3, just FYI.
Yeah, but and like that's not in the docs right now, and like the docs are 99.9% the same.
Yeah.
But that version number is different, and it could cause some confusion.
How does the audit work for your compiler? Are you guys doing external audits?
We are doing external audits. We're doing internal audits first, just because our team's obviously the most aware. But if we can't only do internal audits, right? Because we're too close to see certain things. So we do have external audits staged as well.
External audits. Do you call like Spearmint or something, or do you call the security firms, or?
Yeah, Savio's been talking to them. Savio's here. He's the PM for Noir. His name's Savio. Yeah.
I'm interested, curious on that side too.
Okay. Yeah, he's definitely the man to talk to. I imagine we'll get at least partway through our internal audits before we're going to do the external engagements. Yeah.
Maybe even do a public audit.
Yep. Yep. And then there's also the proving system side that we need to get audited. I mean, that's crucial for the Aztec network.
There's like a $20 million fund right now for the do audits.
20 million? For ZK VM, I'm assuming?
The whole tech stack. Like provers, the VMs, compilers, all of that. And a lot of people don't know that.
Nice. Yeah. I should introduce you to Savio. Nice. Cool. I'm doing a workshop later on vibe coding Noir. Yeah, it's like 2:30 or something. And I'm just going to show tools that I found to be interesting. And I want other people to come. If you guys are vibe coding stuff, like come share tools, because like literally every day there's new stuff and there's not enough time to explore it all. So it's going to be collaborative and